Oh, hello. After some technical troubles, we are going with the slides are a bit messed up here, but they will be okay on the recording. So today we have Samuel Henrique here to talk about fixing CVEs on Debian. Everything you probably know already, but maybe you don't. I don't know. And he will introduce himself, so let's welcome him.
Thank you for coming. In my defense, I did test the slides at lunchtime and something happened with the projector, so I don't know how to use the computer. I always had a lot of admiration for people who worked in security fixes, especially for Debian, and for years I wanted to get in, and I always struggled. For some reason, it seems like a different type of work when comparing to regular packaging, in the sense that to break through, you need to spend a lot of time all at once. You cannot just spend 1 hour per month studying it and gradually doing things. You need to be able to bootstrap yourself. So with this talk, I hope to make that process easier for everybody who's interested. And at the same time, I'm going to talk about some suggestions on things that I think are the better, on workflows that I believe are the better way to achieve this sort of work, and also show some interesting examples. My name is Samuel Henrique. I am, that's the Brazilian pronunciation of my name because I'm Brazilian. I have been a Debian developer since 2018. I am not a member of the Debian security team, but anybody can contribute to that. Although I am a member of the security tools packaging team, which is the team that takes care of security-related tools in Debian. You can think aircrack or nmap. I also maintain some other things outside of the team, so curl, rsync, shellcheck, and I do some work of mentorship with newcomers who want to learn packaging. That's mostly in the Debian Brasilia group, where we have weekly meetings to help everybody out. For work, I am a system development engineer at Amazon, so I work in the Amazon Linux distribution in the security team. And there's some links there to my socials. Also, I forgot to mention these slides are available in my website. It was here on the first slide. It is somewhat readable, so that's samueloph.dev/slides. And it's also linked in the etherpad of this talk for the DebConf website if you want to reach them. Fixing CVEs is a process that requires a lot of knowledge. You have to be some sort of know-it-all across all different areas of domains. So you have to be a good programmer. You have to have a good understanding of the CVE ecosystem. You have to be good at understanding the Debian processes involved. So the way I decided to tackle this is that first I'm going to give you a brief introduction about the CVE ecosystem. Then we're going to talk about what do the CVEs represent for Debian, because it has a special meaning for us. And we're going to compare how people address CVEs, how people fix CVEs. There's a big difference between how upstream developers fix CVEs and how Debian fixes CVEs. And the last part of the talk, that's going to be the longest one. I'm going to go over each step in detail, each step what you need to fix a CVE, and that's where we're going to start seeing some interesting examples. So maybe not everybody is familiar with CVEs. There are two main things that a CVE might mean. You have the CVE program, which is this American-sponsored project that does a lot of things related to vulnerabilities. And one of the artifacts of this CVE program is the CVE ID. The CVE ID is an identifier for vulnerabilities, and it is supposed to be unique per vulnerability. And in some way, it's global in the sense that we all share the same ID when we're talking about things. So for Debian, for Fedora, Red Hat, Ubuntu, we use the same identifier. So it makes things easier. And the format of this, the CVE IDs is always CVE-year, and you have 4 digits for year and dash a number. So for example, CVE 2024-3094. Usually when people say the word CVE, they mean the CVE ID and they don't mean the CVE program. That's how I'm going to use this word, because it's usually when we talk about this, we are not talking about the CVE program. So if I say a CVE, it's a certain CVE ID that I'm not talking about. There's a lot of work behind the scenes to come up with this project. The the program for attributing CVE IDs. So it is a crowdsourced effort, although there are some centralizing points where you can get details about CVE. So if you're looking for information for a certain CVE, you can reach a certain data feed, and then you know everything will be there. There's, let's say, the canonical place to retrieve this information. The most important thing you have to take away from the CVE is that there are two things, actually. The first one is that the CVE is mutable. It does change with time. It can be rejected. It can be disputed. The description can change. Lots of things can happen. So if you're looking at the data, you need to always watch out for the timestamp of when it was last changed. The other thing is that it can, and it does, contain misleading information from time to time. It can contain things that are factually wrong, and it can imply things that are not true. This is not the blame of anybody specifically. It is a byproduct of the process itself. So you have to take that with a bit of a grain of salt. You need your own verification on that. CVE.org is the website if you want to get more details on how that works. Now, a CVE for Debian is something different, let's say. For Debian, because we need to take care of a lot of packages. I don't remember the number now, it's more than 4,000 packages we have. So the security team has put in place these mechanisms to inject the CVE data automatically, and then they have also manual processes through which they perform the assessment of this data that is coming in. So this assessment sometimes is called evaluation, it can be called triaging. I'm not a big fan of the word triaging because usually I use the word triaging for things that are more simple, and assessing a CVE takes a lot of skills and time as well, whereas usually triaging is something much more simpler. To get an idea of how many we get per day, last year there were an average of 80 CVEs published per day. Now, some of them do not affect Debian at all. They might be for private products, they might be for appliances, so we can straight out drop them. But there's still a good chunk of them that needs manual processing, and it is absolutely impressive how quickly the security team is able to handle that. If you look at the IRC logs, and you see they're doing this, you're going to see them doing this all the time, including on weekends. So it's highly impressive, and it's of high quality as well. CVEs for Debian, they can be fixed by anyone, and it would be impossible for the security team to fix all of that. We have just too many things, and it's actually recommended that if you're interested, you should help. We might release an advisory when we fix something. So an advisory is nothing more than this sort of notification that we fixed something. We have more than one type of advisory for Debian. So you have the Debian Security Advisory, which is the DSA. You have the DLA for the LTS, the BSA for backports, although it's not really used, and then we have Friction's ELA. They're all pretty much the same. So it's an FYI in which Debian is saying, hey, we just fixed these vulnerabilities for this package. You should update your systems. And the process by which we fix the CVEs is also unique for Debian because we do what's called backporting. Now, this is not to be confused with the backport repository. The backport repository is this repository where we provide newer packages for users of stable and old stable, which is something totally different from the backporting process. Whereas the backporting process is the process by which we pick changes for a certain version of a software and we apply them in an older version of the software. So let's say it's a commit, a patch, or a diff, all the same thing. You get one of those that was written by the latest version of the software and you apply in a previous version. So you are porting it back, those changes. And whenever I mention backporting here, I'm going to be talking about this process and not the backport repository. Now, it's time to talk about the big difference in how upstream projects and how Debian tackles CVEs. We can go with a thought experiment here to showcase the differences. Let's assume that a CVE is reported against the version 5 of a given software. Upstream might do a lot of different things, but I wrote three alternatives here that showcase how broad the upstream response can be. Alternative A, or 1, upstream might prepare a fix for that CVE. They bundle with a bunch of other changes they had. Maybe they refactor the code, they have changes that are not backwards compatible, and they release all of that as version 6, and there you go, it's fixed. right? Alternative number 2, upstream might push a fix as version 5.1, assuming semantic versioning here. 5.1 is still backwards compatible with 5. They push a fix, but they don't say anything about version 4 because they don't support that version anymore. It's end of life. And alternative number 3, upstream is extremely nice and kind, and they will write an extensive report where they're going to say, this vulnerability was introduced in this commit, it was fixed in this commit, these are all the affected versions, the range of affected versions. They might go even as further as saying, by the way, if you build your software with this flag, you're not affected. Or they might say, if you cannot patch it right now, you can use the software in a different way, maybe a configuration change, and you can mitigate the issue. Now, there are some upstreams that do this type of work, but I think the core project should be especially mentioned here because the work that they do is incredible. I've never seen something like that. When you read a code advisory, you see all of those details, and by doing that, they are making sure that everybody that uses curl is secure, because it makes it very hard for a distributor of that software to mess it up when it's clearly called out on the upstream page. Now, let's think about how Debian will tackle this. So in the same scenario, but going with alternative number 1, upstream has released something as version 6, a lot of changes that could break the behavior for the user coming from version 5. In Debian, we might be shipping version 5 on unstable and testing and version 4 on stable. So how do we solve this? We cannot just package version 6 for stable because it's going to break everybody, right? We need to find a way of applying this fix. So that is effectively where backporting comes in. We will identify the fix, we will isolate the fix out of the version 6, we apply that on version 4, and then we release a new package that's going to be version something like 4.0-1 plus, and then some identifier. So in the case of Debian 12, that'll be deb12 u1, update 1, the first update of the stable series for that package. For testing unstable, though, we can just package the latest release because the user will understand that if they're doing a major version upgrade of Debian releases, they have to test things because dragons breed there, right? Optionally, we will release an advisory for the fix as Debian. Now, this is an overall overview of the steps on how to fix a CVE. You need to find something to work on, confirm there is impact, identify the fix, then you do the actual work of applying these patches, you modify them. It's very common to have to modify patches, so that's the gist, that's the root of backporting. Usually you cannot just take a commit and apply because the source code is all different. It might have been refactored in the meantime, so you need to modify the patch to be able to successfully apply it. You want to document that as best as you can because you want to be able to review it. Test the changes, you have to make sure you're not breaking anything. Submit them, and after they're submitted and shipped, you still need to be careful and watch out for bugs reported by users because some things will only break and be noticed after the fix is out. And the worst thing that can happen is that you fix a CVE and you stop paying attention to it and something comes up and nobody's looking at it. Now we're going to go over each one of them with some examples and talking a bit more about it. And by the way, backporting, I'm only focusing on backporting here because merely packaging the latest release is regular packaging work. There's nothing special about that. First, you need to find something to fix. It might not be so easy for newcomers, but you should check out the security tracker. So that's security-tracker.debian.org. It will have lots of documentation, lots of nice pages that allows you to filter CVEs by package, by severity, by whatever you want. And maybe you see a package that you know how to use and you want to fix something, you can just read the details up there and then go ahead with the next step. It might be better to start with a no DSA CVE. The security team will flag some CVEs as no DSA, which means that they are not as important, so to require a DSA. So it's a good starting point for a beginner. And they will have there's a different mechanism to push this change. So no DSA CVEs go through the proposed updates mechanism, which is a process defined by the release team. Whereas DSA CVEs will go through the security team. So they require some coordination, different type of coordination. And if you end up working on a DSA CVE, you need to consider using that as an opportunity to also fix whatever you can about the package, whatever you can in regards to other CVEs, obviously. So at any time there's a need for a DSA CVE, we look at all of the no DSA ones, and we try to fix all of them at once, so then we can use the advisory and say, oh, all of these CVEs were fixed. Check if the CVE has been acknowledged by the upstream developer. There are cases where upstream is not aware that someone has filled a CVE for an issue, and there are cases where they have a very strong opinion on that being a vulnerability or not. And in these cases, you should likely not fix the CVE. So then, again, not every CVE should be fixed. It requires some experience to understand these cases, so you can always ask someone in case of doubt. And this is not readable at all. Sorry about that. But in this screenshot over here, or maybe it is, no, it's not readable. In this screenshot over here, there was an interaction that I had with the Python project back in August last year, where I've noticed that there was one CVE that was pointing, one CVE for cpython, which is the main Python interpreter by the Python Foundation, and it was pointing to a GitHub issue, and it was looking like the Python folks didn't know that it was a CVE. So I left a comment there, and they replied they were grateful about it because they did not know. And it turns out that on this case, it was a batch of more than five CVEs that they didn't even know about. So with this notification, then they can pull the CVE into their own processes, and they provide more information about it. So then they can say with more precision where is the effectiveness and the nuances of this. Another thing that happened last year, there was an interesting one. That was a curl CVE. I struggle to pronounce curl every time. That's a CVE-2020-19909. And this is a screenshot of the blog post by Daniel Steinberg. It's one of the curl developers. And the blog post is titled CVE, the ID, is everything that is wrong with CVEs. It turns out that someone has filled a CVE that first of all, it wasn't a security vulnerability whatsoever. They did not notify the core developers, and when it was published, it was scored as a critical CVE, which is of the highest severity. So some of the things were huge red flags, so I was the one who notified them, and that's only because when I saw the CVE, I instantly knew something was wrong because it wasn't coming from the usual places where you see curl CVE coming from. They were not as detailed as curl CVEs are, and it was looking sketchy. It wasn't looking like a CVE. So this blog post is interesting because it talks about the process overall for CVE assignment. Cryptographic libraries are especially vulnerable to timing attacks. So if anybody is not aware of timing attacks, we can use as an unrealistic example. Think about a function that take a different amount of time to run depending on how many characters of a password are correct. So let's say if you send it 2 characters of a password that are correct, it takes 2 milliseconds. If it's 3 characters, it's 3. Now, if an external actor is able to trigger this function with random payloads and they can time in the execution, they can basically brute force a way in to know your password. Now, this over here, this is a CVE fix for a different timing attack. So this is a real timing attack that happened, and it was on the GnuTLS project. Now, the interesting thing about this is that the fix for the CVE is the removal of an if statement in which one of the branches will say log, and the other branch will say debug log. And not only that, but in the comments of the function, you're going to see someone explaining that acknowledging that this might be prone to timing attacks, but they have taken protective measures against it. Turns out it wasn't enough. So for 4 years, this CVE was there in the GnuTLS code base, and they did not notice. Now, the point I want you to take from this, they are experts in what they're doing when they are GnuTLS upstream. You have to ask the question, if you were working on a CVE fix for a cryptographic library, would you be able to spot whether or not you're introducing an issue like this? And you also need to consider that timing attacks are also dependent on compiler optimizations and build flags. So it's not even enough to only look at the source code. You also need to understand how it will actually get built. And this means that it's risk assessment, basically. You need to look at this and you need to make a judgment call whether you can safely do this, because there will be cases where you're going to say, this is too risky, we're not fixing it. And it's a balance. It depends on the severity and the risk of regressions. Next step, we have to confirm impact. The key for confirming impact is understanding. You need to understand what is the patch doing. You need to understand what is the vulnerable code doing. And you need to understand what the vulnerability is about. You should read external descriptions about the CVE. You can check on the OSS mailing list hosted at OpenWall. You can search on Hacker News. You can search on any search tool and see if there's more information about it. You need to consider that some CVEs are dependent on certain build flags being used on that software. So sometimes, which is the case I mentioned, sometimes if you build a software with a certain tool, you're not affected anymore. But I should also note that on the security tracker, when these things happen, we still mark the CVE as affecting the package because we are talking about the sources. So if the vulnerability is in the source of the package, we are going to say affected and unimportant, which means that the resulting binaries are not affected. I understand this can be a bit confusing to the users, so I am working with the security team and how to address these and hopefully provide more precise information, even more meaningful information by clearly calling it out which case is which. Sometimes hardening will block the exploitation, and hardening usually doesn't deny the exploitation, it changes the impact. What hardening can do is, instead of a information disclosure vulnerability, it becomes a DOS, because the moment the software tries to access memory that it shouldn't, it's just going to crash. So it's usually still a vulnerability, but it changes the impact. There might be some cases where it actually denies the whole vulnerability. Check if the vulnerability itself was backported. There are cases where the vulnerability was introduced as a fix for another vulnerability. There are cases where a vulnerability was introduced as a bug fix, a critical bug fix for something else. And those are tricky because you need to check if we had backported that in other releases that we ship. If you find anything that is not on the security tracker, send a merge request enriching that information. Anybody can contribute to that, and it's on Salsa. You send a merge request updating that. The documentation is on the security tracker, documentation on how to do that. Sometimes the affected code is also bundled into another package. There are some libraries that people tend to bundle in for other packages. We try to avoid this on Debian at all costs, but sometimes it happens. So you can use codesearch.debian.net to search for a function name, a function signature, and see whatever package has that. Understand which Debian releases are affected. It's good to have this foresight of, okay, old stable, old stable are all affected. Even maybe backports has a vulnerable version. And do not trust the CVE description without verifying it. We have an example here. This one, not readable either. This is a Wireshark CVE, CVE 2024-2955. And in the description of the CVE, it's going to say that the affected versions are between 4.0.0 and 4.0.420. Sorry, 4.0.0 and 4.2.0. Does this mean that 3.6 is affected? We do not know. We only know that they are claiming these are the affected ranges. There are multiple reasons for which 3.6 might not be here. Maybe the reporter didn't even investigate. Maybe 3.6 is end of life, which is the case here, and Wireshark is not even checking, right? So we do need to check those things. And for the record, this is not the fault of the Wireshark project. After all, they should only care about what they support. And this is what we do as a Linux distribution. Our work is to make sure we are shipping things correctly and working and supporting that. So if we ship version 3.6, we need to provide support for that. Another common pattern I see on CVE descriptions is the text of this paragraph that says, users should upgrade to version X to fix this issue. This is an Apache CVE where they're mentioning that. And that can confuse users because they might be using stable, which has a lower version, let's say version X-1. and they will be looking for this newer version to update to, where this is not going to happen because we're going to backport the fix. We're not going to package the latest. So whenever you're in doubt, use the security tracker as your resource for this information. And again, this is not the fault of the Apache project in any way, shape, or form. This is our work. This is what we have to do as a distribution. We see in this screenshot the notes for that same CVE, the Apache CVE. It's slightly more readable now, but you're going to see some Node.jsa markers there. You see that Debian, the security team, has pointed out where is the commit that fixes the issue. And you can also see a mention of this was introduced due to a fix, as a fix of another CVE. So now there's a red flag there. We need to check where did we fix this, and we need to go there and update that. This is 2 pieces of a curl advisory for a CVE. I purposely cut out some parts to make it less informative and mimic most of this, what you get in most of the CVE descriptions, right? This is even better than what you mostly get as CVE descriptions. So it's going to say when saving HSTS data to an extensive long file name, blah, blah, blah. And then you have affected versions, and they are very precise about this. It's going to say 7.84 to and including 840. Now, let's pretend we ship 786, which is within the affected range here. Can we say we are affected? Maybe. You need to check. And in this case specifically, if you don't build curl with HSTS support, you are not affected. So you need to be careful about this. Now, the part that I cut out of this is the explanation for that. So curl will say, oh, if you don't build with HSTS, you are not affected. We don't get that for free most of the times. You need to find a fix. If the fix is not listed on the security tracker, you need to find it. And you can start by checking if any other distribution has patched it, if it's an old CVE. I like to use repology.org to find the Git repositories of other distributions. And then from there, you're going to need to learn the basics packaging for our distributions, but that's always a good thing, in my opinion. And you see if they had patched it. If they patched it, you need to check if they also found any type of regression or if they modified the patch, because it's going to be useful for you. Let's use the power of free software for this type of thing. Consider that recent fixes can have hidden regressions. It is much more likely that a fix that was pushed just yesterday has some regression that has not been spotted yet. So look around the corner, right? Use this as part of your risk assessment and make an investigation to find out if someone has reported a regression already or if a fix has been pushed to the Git repository and not being advertised yet. Identify any unexpected behavior changes that might arise from the fix, because we don't want to be introducing this in Debian stable. Some examples of behavior changes are features that are removed. And sometimes, in order to fix a CVE, the whole feature is just dropped from the software, and we don't want to do that on stable. It depends. Again, it depends on the severity, but you need to consciously make that decision. You need to be aware of this. And the introduction of operation limits is also something that catch people off guard. This is an example of that. This is one of the commit for a curl CVE. I'm giving a lot of curl examples because I maintain curl and they're a good source of this data. On this commit, the commit title says cookie column apply limits. So it's there. It's explicitly calling it out to you. Sometimes it's not like that. And then they talk about how they have at least three new limits for cookie-related operations regarding maximum amount of cookies per request and maximum size. So when you see something like this, you need to ask, is this going to break our users if I push it to stable? And you will never know exactly, because the limit, you can never choose a limit that is good for everyone. So the limit is X, and there might be someone that depends on X plus 1. If you push this to stable, you break them. Whereas then if it's too risky and you don't want to push it to stable, you save it for Debian testing, so the next stable release is going to have it, and the user has this opportunity when they are updating releases to do their checks first. Another example here, this is a free IPA, a Git log of the project free IPA for the series 4.6. They were really nice. So the highlighted commits are fixes to a CVE, and they were really nice to backport them themselves to version 4.6. Now, if you're working on this, you might say, this is perfect, I'm going to put this into the package. But now, pay attention to the commit that is right on top of that. It's going to say, fix Python 2 issues. And that was pushed a month later. Now, this is fixing a regression introduced in the previous commits. You need to ask the question now, if you were working on this, would you have noticed this? Let's say the fix is there already. Would you have done your work and check the Git repository to see if there's something more? Let's say the fix is not there yet because you're patching it too early, right? Would your tests have identified this? Your package might have 2,000 tests. If they don't reach the code path that you're changing, they're not testing your changes effectively, right? So you need to be careful about that. Let me just get some water. Right, so apply, next step now is to apply the patches to the packaging. It is crucial that the process you follow makes it easy for collaboration and reviewing. So first thing I suggest, obviously use deb3 branch names. We do this Git namespacing thing for Debian packaging, which I absolutely love it. Push it to salsa, right? Do not let your code editor format patches, so eventually you're going to open the patch in your code editor. Don't let it auto-remove white spaces. Don't let it replace tabs or spaces or vice versa, because this will break the patch, so be careful about that. And then you start with one commit that introduces the unedited patch. So pull the patch as it is on upstream, commit that to the packaging, and then you add them to patch series, so you try to build and see if it works. If it works, you can go ahead with testing any other parts. If it doesn't work, though, now it's effectively this is the root of backporting. You need to start investigation. So it becomes an investigation work. You can use gbppq to help you with that, and sometimes you have to modify a patch because a function got renamed or a variable got renamed in between the versions. But if you change that, you need to make sure that they mean the same thing still, because they might have changed behavior as well. Some other times, another patch will be a requirement of the fix, so then you need to go back, pull that other patch first, which is a requirement, and then you apply the real fix. But you need to be very careful about introducing new functions. In the scenario where, for example, the fix is making a call to a function that didn't exist at the time in the code, it's very tempting to just fetch that function and manually patch the function in the old version. But now you're introducing risk here, because are you going to pick which version of the function are you going to pick? Are you going to look at the latest whatever is on master, mainline for the upstream project, pick that and add it in? And after you do that, who's taking care of making sure the bugs of that function are being addressed? Maybe that function has a CVE eventually, and it becomes hard to track, hard to see that it's there. So risk assessment, again, sometimes it will make sense, sometimes not. For every change that you do in the upstream patch, make sure you document that in the patch headers. So go in the patch headers and add a backported-by line and use it as a changelog. Describe everything that you did there, because after you do this, you want to go back and see if you did anything wrong. And when you look at the changes, you need to understand if you did something on purpose or not, right? So by doing this, you're calling out in the header of the patch, you're calling it out which changes are done on purpose. And if anything doesn't match, you know something went wrong. And then you do one commit only for the backporting changes. So after you do all the changes you need, you push a commit with that. Overall, you have one commit that imports the unedited patches, one commit that imports the backporting changes, and one commit that updates Debian changelog. You don't want to update Debian changelog as part of another commit, because it's only going to make your life harder when you end up needing to cherry pick this. If you fix on stable and you have to fix old stable now, you want to be able to cherry pick the patch from stable instead of starting from scratch from upstream. We have a screenshot here that is a curl merge request. It was done by Guilherme Puida. And on this GIF, you can see that he's updating the patch headers to add the 2 lines. One line says backported by his name. The second line describes what he changed in the patch. So it's very easy for me then to look at this now, and I see both the description of what was changed. If I scroll down below, I'm going to see what was changed, and I see if that matches. If it doesn't match, something went wrong. This is how the commits should look like. You have in the bottom there, you have a commit importing 2 patches, 2 upstream patches without any changes. Then you have 1 commit that is adding those patches to the series file, so they effectively start getting applied. And then you have 2 commits, the ones in the middle, which are doing the backporting changes. And at the very top, you have the Debian changelog. Now, think about how you can review this now. It became easier to review it because the bottom commit, you have to review things differently, right? You don't review the upstream commits the same way you review the Debian changes, because the Debian changes are things that we are doing it specifically for us, and we need to be possibly even more careful with that. So you can have a single commit where you review the upstream changes, and as part of the review, you can maybe check if it matches indeed what's on upstream. If you are the person who did it, you might not even check that. And then you check the backporting commits one by one, where you can see all of the changes done. So that's already getting into the review the backporting part. Reviewing backporting changes, it's quite special because effectively a CVE fix is a patch, so it's a diff, and the backporting changes is a patch on top of a patch, so it's a diff of a diff or a patch of a patch, if you will. And it's interesting to review this type of thing. I think it's very I enjoy doing it because of the challenge, and it's something that you can actually do it, right? So you want to make it as easy as possible to do it, right? You have then splitting commits this way, it just makes everything easier. At the end of the day, if you claim you release something and it's not really fixed, we need to release a new CVE just to clarify, by the way, this is not fixed. Now there's a new ID to track this because it became a different thing. And at that point, you become a CVE alter. But that's not the type of CVE you want to be altering. Mistakes happen anyway, but we need to avoid that. Pay attention to how hunks are moved around in the patch when you're doing backporting work. Sometimes the diff will change in a way in which hunks are moved around, and if you're reading the backporting changes line by line, you're going to get confused in the beginning because you're going to see a huge block of code that was just removed, and it doesn't make sense until you get to the bottom and you see that thing being added again, right? It's because it just got moved around. So first of all, do a high-level review of the patch, and then you go deeper line by line. Oh yeah, sorry, I think I skipped. Question everything. So in this case, we have a CVE fix for a curl memory exhaust. It's a memory leak for curl. Again, this is part of the fix, and what you can see here on the diff is that one function call is being replaced by another function call. So instead of curl save free, we have free push headers. The main question you need to ask when you're reviewing this is, we are replacing a function call by another call. Are there any other places where I need to do this change that have not been identified by upstream? Because again, upstream is patching the latest version they have. In the previous version we have, instead, we might have extra calls to this function that got eventually removed. And in this case, we need to be very careful, see if we need to apply the same change to these other calls. And it's not even as simple as that, because under certain contexts, it might be fine to still call the old function. So you have to understand it. And but it's all feasible, right? You just need to be aware of the need to do this. Testing the changes then, not much I can say about that. So check if other people have tested already. For example, upstream might have pushed a regression test, and it's going to be on their Git project. So look it around the Git repository. Maybe other distribution has pushed a test for it. This is rare, but it can happen. Consider the usage of a reverse dependency for your testing. Sometimes a reverse dependency will have a thorough auto pkg test. So you can trigger that test, which is going to use, again, your package as a dependency. And that test might be able to give you some information. If there is a proof of concept available, run it. Run it before you do the fix. Run it after you do the fix. But most important of all, understand what is the expected outcome of the POC. There are lots of cases where the difference between a POC confirming affectedness and the POC crashing is very small. So people might see a crash of POC and think that it confirms there is impact, where it's not true. So understand what is the expected output of a POC when you're running it. Submit the fix. Again, mention the CVE ID in the changelog, so Debian systems can pick it up and track that correctly. Follow the right update process. If it's a proposed update, if it's a no DSA CVE, it's going to go over the proposed updates mechanism by the release team. If it's a DSA, it's going to go through the security team. And again, watch the BTS for users reports, because they might report something after the fix is out. Now it's time for questions, but in any case, I'll be around the whole DebConf, so feel free to reach out to me. I enjoy discussing these things. How much time do we have for questions?
We have one question. Sorry.
Okay, we have time for one question. That's what he said. I've got a question here.
Hi, my name is Mark. In your example with curl and the broken CVE system, the kernel, for example, has become a CNA. What are your thoughts on projects becoming CNA?
Oh, this is... what can I say about this? Yeah, for those who don't know, the Linux kernel project has become a CNA. And out of nowhere, they started pushing 400 new CVEs a day. And that's why in the average amount of CVEs, I'm only saying 2023, because that number has grown considerably since then. And basically, the kernel project is claiming every commit is a CVE, kind of. It's automatically. So they don't even check exactly if it's a CVE. And it has been a source of lots of discussions. There's not much I can say besides, like, it's an interesting experiment. No, já acabou? Okay, that was all. So thank you very much for coming.
So let's thank him.